Last time we started section 1.2, we were looking at exploration with patterns. And we left off on my not so eloquent description of figure-it numbers, where I drew pictures and left things out. But we fixed it, and we had these pictures when we were done. We talked about the numerical pattern that we could create by just counting the dots or the number of dots in these figures. And then we took a look at the fact that if we went to the second differences, that is if we did the differences twice, we ended up with an arithmetic sequence. Okay? So, or we ended up with a common difference is what I meant to say. We ended up with a common difference. We're going to do one more set of figure-it numbers. We'll see if I can get the dots on here in the right place this time. These are square numbers. So your first square number has 1 dot. The second square number looks like a square with 4 dots.
So these numbers are really like the numbers that you would, like the amount of dots you would need to make a square.
Yes.
Make a triangle.
You're right. Mm-hmm.
Okay, just checking.
Okay, I think I've got enough dots on my screen at this point. So this is the sequence or the pattern. If I were to draw the next dots in the sequence, what would it look like? Yeah, it would look like 5 by 5. 5 dots wide, 5 dots tall. All right, so what I'd like to do is I'd like to write out the numerical pattern that we have here. So what is the pattern that you see?
1, 4, 16.
Okay. Now, if you were to write an equation for this, you would probably be able to do it pretty easily, because what kinds of numbers do you actually see that these are in number written out form? What are these? There's the squares, which kind of makes sense because these are supposed to be the square figure-it numbers, right? So if I were to write out a general form, the general form here is actually n squared. It's not geometric, it's not arithmetic, but it's just the term you're on squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth, okay? So this is actually one where we don't have a arithmetic or geometric sequence, but it's pretty easy to see the general pattern and to create a general form for the number. Now, that aside, even if you didn't have that, you could take a look at the first and the second differences and see that a pattern will also emerge. So I'm going to write it out to 25 because it'll be a little bit more helpful.
Is there a reason
Yes.
to skip the 9?
I guess. Man, you guys are so picky. In seriousness, thank you. Yes, we do 9. Okay, let's see what happens. We're looking for that arithmetic, sort of sequencing that we've done before. I would have to add 3 here, right? Sorry, my pen is not really acting very cooperative today. Keep skipping. All right, how about from 4 to 9? I would have to add 5. And then I'd have to add 7. Then I'd have to add 9. And that's not a common difference because they change. All those numbers are different. But if I did the second differences, what would I get? I'd see the pattern very quickly. And you probably saw the pattern before for the next one. But it's the second differences that actually show the common difference of +2. And it becomes very clear. So this is also a second difference form. Okay, we have one more question for this section. Told you we were almost done. This is a for real life, it happened sort of scenario. So do not tell anybody beside you your answer while we do this description, okay? Read it and write down your answer. That's all I want. So this is a not collaborative activity. In the fall of 2011, which was my second year at OBU, the newly formed Hurley College of Science and Mathematics had a meeting. On the board, the dean at that time, her name was Dean Blue at the time, wrote the value 3.1415 ... And she asked us to find the next 2 terms in the sequence of numbers. Okay, so now you pretend that that's what I did and I put that on the board. What would you say are the next two terms in this sequence? Explain your reasoning. Don't talk to your neighbor. Write your answer down and explain your reasoning, and then we're going to talk about it. I need one volunteer that was willing to say what they wrote down. Just one. Okay, Kelly?
Well, I put the next two terms were 1, 6, because it looked like it was going 14, 15, 16, 17.
Okay. So by show of hands, who put 1, 6? Okay, did anybody not put 1, 6? What'd you have, Brianna?
Honestly, I could not.
You weren't sure what to write down. Okay, that's fine. Did anybody have a different answer than the 1, 6 though?
I didn't know what to do.
You weren't sure what to do either.
I did think that it wasn't 1, 6 because it's 3.1415.
Okay, so 3 point maybe.
3 point something something.
Okay, what do you think, Ariel?
This isn't what I put, but this is also like pi is 3.141592.
Okay.
That's what I
Okay, so those are the two different options for the things people wrote down in that meeting. So some people, in fact, honestly, nobody in the meeting did what you guys did. But one possibility is 1, 6 is what you wrote. And what you're seeing is that you're looking at this as 1, 4, 1, 5, 1, 6, that that's a pattern. Okay? Everybody in that meeting wrote down what Ariel suggested. 9, 2. Why would everyone in that audience have written 9, 2?
because they're all pi and science.
Oh, math and science people. So we saw 3.1415 and we were like,
1, 6.
it's pi, right? 9, 6, or 9, 2. So we said it's pi 9, 2. And in fact, we thought, kind of like probably what you did, at least most of you thought, well, it's obvious to me. It must be this, right? So Kelly, kind of, even the way you said it, you were like, well, it looks like it's 1, 4, 1, 5, 1, 6. What's the big deal, right? You saw something different because your experiences coming into it gave you a different perspective, okay? So what I want you to notice about this is, what does this tell you about what we did there? That exercise was an exercise in inductive reasoning. We took a specific example and we tried to generalize what we thought was going to happen next.
People can do it differently, and they can come up with different ideas, both looking at the same specific example.
And they could both be equally right. Right? There's nothing wrong with you guys writing down 1, 6, and there's nothing wrong with me seeing that and thinking it should be 9, 2. We generalize based on different experiences, right? So there may be more than one legitimate generalization on a pattern. So inductive reasoning can be very, I don't want to say scary, but it can be very inaccurate. Yeah? And we do this, of course, in our lives all the time. You know, you're thinking one thing, and then your best friend or your boyfriend or your mom or somebody in your life had something they were completely otherwise thinking of, and you both draw different conclusions, and you're looking at each other going like, where did you come from? Right? Because we have different experiences that lead us to that same spot where we're making a decision from a different perspective. Okay? So inductive reasoning is not always fail-proof. Sometimes it doesn't work very well at all. All right.